All springs, coil, leaf, or torsion bar act to keep the tires on the road and reduce up and down movement of the frame. But springs are subject to continuing vibrations after a vehicle has passed over a bump. Let's look at how this happens.
Remember the response of the spring in reaction to a bump in the road. When the spring uncoils and pushes the wheel back to the road, it releases stored energy.
But the release of energy creates a cycle of movement called jounce and rebound.
When the spring is compressed, it is called jounce, and when it extends, it is known as rebound.
The cycle of jounce and rebound would make the ride in a vehicle equipped only with springs very uncomfortable.
So, cars have components designed to control spring movement called shock absorbers.
A shock absorber is a device that offers a resistance to the spring's natural movement. Shock absorbers do not normally support the weight of the car.
Most cars use direct, double-acting hydraulic shock absorbers.
On many front suspension systems, the shock absorber is attached at the top to the frame and at the bottom to the lower control arm. In rear suspensions, it may be attached to the top of the frame or body and to the rear axle. Let's take a look at how a shock absorber works.
The direct, double-acting hydraulic shock absorber contains a piston in a fluid-filled chamber. Since fluid can't be compressed, movement of the piston within the chamber is limited to the rate at which the fluid can flow from one chamber to the next. For example, when the wheel hits a bump and the spring is compressed, the piston in the shock absorber is also pushed downward. But in order for the piston to move, fluid must be displaced from the lower chamber below the piston to the upper chamber above the piston. To do this, the shock absorber uses a one-way valve along the side of the piston. The downward movement of the piston is controlled by the rate of fluid transfer between the lower and upper chambers. Fluid is also displaced into a reservoir, allowing more precise control of piston movement. As the spring rebounds, the piston is pulled upward in the chamber. Now, to control the upward movement, the process is reversed. A separate one-way valve along the opposite side of the piston allows fluid to move from the upper chamber to the lower chamber. The rebound action of the spring is limited by the rate of fluid transfer within the shock absorber.
In some cases, the action of the shock causes air to mix with the shock fluid. This is called aeration. Aeration reduces the effectiveness of the shock.
A gas-filled shock absorber is designed to prevent aeration. A gas shock typically uses a cell in the fluid chamber that is filled with an inert gas like nitrogen. This replaces the reservoir in a conventional shock absorber. As the piston in the shock moves up and down in response to bumps in the road, the gas-filled cell resists mixing with the shock absorber fluid. This eliminates the effects of aeration.